Hello guys and welcome to this one. And yeah, today we're going to be looking at something interesting, and it's going to be finding the highest number in a list. And how do we go about doing that? We can go about that in a way we'll just find out in a bit. Sorry. So yeah, the highest number in the list pile is the bone of contention here, just as I just said. Take up manipulation of values with the recursive function, but how? We'll find out. So basically talking about finding out how we manipulate values, to get our answer in a bit. My solution is one that drew knowledge from the previous implementation. So in this time around, this was one of the implementations that I got right off the bat, and I wrote an elaborate implementation that would not necessarily be optimized subsequently, but would be modified in a sense because optimization is speaking to like me bettering the code. But yeah, we are going to be using less of variables but the same O of or the same complexity. But yeah, we are going to see that in the part two of this. So to get into the part one, let's see how we cook. So we call this thing called find highest, and we declare our base case. So now on the base case, how what do we think the base case would be? The base case would obviously be when the index has transversed to a point where it's now at the length of the array, meaning that it has gone through the entire array to get to the latter end. Before moving further, I would like us to. I made this note when I was trying to get this stuff done, but I don't know what exactly it's doing here. But yeah, it is what it is. I would like us to look at the three, right? At how these three make sense. Because every time we're talking about recursion, we're talking about a tree that stresses out or branches out, or sometimes it's linear, just like this guy over here. So we see we have a linear tree. So let's start from the top. We're taking our instance that this is our values, and then we go on. So h highest is instantiated as 0, index instantiated as 0, and then array, right? And then highest number becomes 1 from our solution. So basically we state it as 1. 3 becomes highest on the second level or the second depth. Depth 3, 7 becomes the highest. uh, at 4, when we have a value of 3, index of 4, there's no change because 7 is still greater than this guy, and a lot of it. So we are going to just look at how we did that in the code. So we said if the highest is less than array at that index, that highest should be replaced by that index, and that's basically it. And then we go ahead in our recursive, and then in our recursive case, we can then go ahead to see, we can then say return find highest, right? We are calling the function again recursively, and then we're passing in index, and we're increasing index immediately, and never return to the call on the recursive case. Yeah, basically I think what I'm doing here is writing out the mistakes I made while going through this stuff. So yeah, so we go ahead to print, and then we see our, and we obviously all know that our time and space complexity is O of n and O of n. O of n because we transverse through the entire values, and O of n is space because we are running a recursive stack. I think we've drilled on that again and again, right? So we're going to set our pointers, and we're going to be seeing exactly what our stuff is doing when we are running running it in the when we're running it in the debugger, right? So let's see. I've clicked the debugger. The debugger is going to be spinning up right now, so we get the experience very soon. So let's drop our terminal and let's move in. So when we move in, we see that we have our index at index of 0, and we have all our values, right? So the if statement is not satisfied, so we skip over. We still have index, and the highest right now is 0. So we move ahead Same stuff. Here we call return. Index is 0, highest is 1. Highest has now become 1. That is the index at the value of at the index of 0, right? And then we have array. So basically we transverse. Now we are at the index of we are still at the index of 0, right? Yep. Now highest has been moved to what? To 1, just from that line that was being highlighted. Now we move on. Our index has now gone into a depth. That's our recursion. It's the second stack, and then we see the index becomes 1, and then we go through again, and then yeah, highest becomes 3. Index at the value of 3. You can see highest here become 3 immediately. You can see it here. You could also see it here. So we go again at the index of 2 now. This guy becomes highest becomes 7. You can see it if you watch this stuff recursively call. And yeah, basically that's it. So now when we get to 3, where you know the highest between 3 and 7 still remains, right? We could see here that 7 is unchanged by that, and we could move forward. And now we're in the first stack, and the first stack is the one that holds 9, and you see 9 immediately updates it here as a stack. So basically that's it for this one. You could see that the highest value is now finally held in the highest value or the highest pointer, and then eventually returned. So that's just the whole idea for this one. It's more of brute force as well. So yeah, but basically the idea is recursion. So muchas gracias, I'll in choose. See you on the next one.